Year 7s, you're all back. I knew you'd be back, given that you've all got just an utterly insatiable appetite for adding and subtracting fractions. I knew you couldn't stay away, so let's get into it. You're probably sick of answering easy questions now about fractions. Let's do some really, really tough ones today. Let's up the difficulty and give you guys a real challenge, finally. Just as a recap of what we went through in our first class for the week, we asked you to add together fractions that had the same denominator, and just deal with things like that. So what we've got is a question here where we're adding together 1/8 and 2 more eighths, and we've got three options down here. One of these options is tremendously right and perfect. One of them is tremendously wrong and going to make us very angry. Then there's one answer that's kind of neither right nor wrong. It's just there. So you've got 5 seconds to think about it before I say the answer. And the answer to this question is, of course, A, because you were warned that when you are dealing with fractions that are the same on the bottom with their denominators, then you only have to add the top, right? So 1/8 plus 2/8 makes 3/8. Okay, this was a question about eighths. It's asking you how many eighths you've got. The number 16 shouldn't come into it because eighths and eighths don't make 16ths. So this is the answer that is tremendously wrong, would make us furious if you put it there. If you thought maybe C was the right answer, well, at least you can make chips out of it, so it's not the end of the world. Okay, we'll accept it. So the reason that we're back for another round of adding and subtracting is we need to learn how to add fractions that aren't the same, that don't have the same denominator. And rule number 1 for addition and subtraction is that in life, as in fractions, you can't just go around adding and subtracting things that are different from each other. If you're wondering what rule 2, 3, and 4 are, etc., there are no rule 2, 3, and 4. There is only one rule with adding and subtracting. Don't add things together that are different. So what does this one rule of adding and subtracting mean for our fractions work today? It means we want you guys to avoid a really, really common mistake that we see students do over and over again. What these students do is they see two fractions next to each other with a plus symbol between them, and they just want to get in there and just add them together and write down an answer and move on with their lives. They want to do something like this. They want to put a 2 here. They want to put an 11 there, and they've added the tops as they've been taught to do, and then they just add the bottoms because they can't think of anything else they could possibly do, any working out that they could show. They just want to add some stuff together and move on. We're not going to let you move on with your lives until you actually learn how to do it properly, right? So you cannot just add the tops and add the bottoms, because as you've been taught and as you've been warned, you never add the bottoms of two fractions together. So for those of you out there that like food a bit more than you do fractions, we'll just chuck a metaphor your way to show you the complete and utter folly of adding things together that are different. Would you add apples and oranges? You can't add apples and oranges because they're different, right? If I have an apple and another apple, I can kind of simplify that statement by saying I have 2 apples. Right, I can actually combine these two things together into one statement because they are the same thing, right? I don't go up to somebody with an apple in each hand and say, I have an apple and I have another apple. I just say, I have 2 apples before they give me a funny look and walk away. Same thing here, I've got 2 oranges, right? 1 orange plus another orange is 2 oranges. But is there an easier way of saying that I have an apple and I have an orange? Can I combine those two concepts? Can I drag these things on top of each other and make some kind of funky orange or apple? I cannot, right? Apples and oranges are separate, so they stay separate, right? I have 1 apple and I have 1 orange. You can't add them together. So if we can't add apples and oranges, why on earth would you think that you can add fifths and sixths? When you get your questions today, do not just try and combine them without doing an in-between step we're going to show you soon. So to show you what we're going to be doing with our fractions, let's just stick with the fruit for a minute. Since we don't want to have 2 different types of fractions, or for some reason, if we're really picky about our fruit basket, we don't want 2 different types of fruit, if we're going to put our different fruits together, we're going to have to turn them into something that's common. Okay, so we could go visit the fruit trader. I guess that's a thing, right? This fruit trader says you can have 2 bananas for any apple you give me, right? So we'll turn that into 2 bananas, 2 of them, and any oranges are worth 3 bananas. So once I make this exchange and I convert my apples and my oranges into bananas, now I can finally add together the fruit that I've got, and I can say that I've got 5 bananas, and now I'm not stuck telling someone that I've got 2 different kinds of fruit. I've just got bananas. Okay, same thing's going to happen for fractions. If we can't add them together because they're different, why don't we turn them or convert them into something that is the same? But since we can't just add these two fractions together, the fifth and the sixth, because they are different sized pieces, right? They're different fractions. They don't just go together. The big question you're going to have to ask yourself and show when you're working out is what's a bigger number that 5 and 6 are factors of? You know, what number does 5 and 6 do they both go into? Because that's a number or a type of fraction that we can turn both of these into so we can actually add them, right? So we're not going to just get on with adding them. We're actually going to convert them into a common denominator because adding fractions with common denominator is really easy. Just add the top. But you've got to have that common denominator first. So with this one, we're going to ask ourselves, what number do 5 and 6 go into? The easiest way to find a number they both go into is multiply them together, right? 5 times 6 is 30. That way we're guaranteed that we have a number that 5 and 6 are factors of, because 5 times 6 gives me a factor of 5 and a factor of 6 into a 30. Doing this might not always give you the nicest fractions to deal with, but it'll always give you something to work with. So instead of working with fifths and sixths in this question, we're going to work with 30ths. Okay, but I can't just put ones on top here. We have learned how to turn fractions into something with a different denominator, but also change the numerator, right? They have to be equivalent, right? 1/5 is not the same as 1/30th. I have to think about how fifths turn into 30ths, what's equivalent there. So to turn a 5 into a 30, right, we times it by 6. For this fraction to be equivalent, I really have to times the top by 6 as well. Otherwise, it's not the same fraction anymore, right? So 6/30ths is the same as 1/5. We're going to do the same thing over here, right? We're going to times this one by 5 to make it into 30. And we're going to times this one by 5 here. And hopefully what you've noticed with this working out here is I'm kind of using the number from this one to multiply this fraction, top and bottom, and I'm using the number from this one to multiply this fraction, top and bottom. All right, that's the easiest way to think about it today. And now I've got 30ths. I've got 6/30ths and I've got 5/30ths. All that's left for me to do is to add those numerators. It's 11, and of course it's not 60ths or anything, it's 30ths, right? It is 11/30ths. Okay, this is how we're going to work and deal with uncommon denominators. So because there are a few steps involved, and also there's sometimes a bit more for you to do once you've actually added your fractions, let's just go through it one more time with a little wrinkle at the end for you. If you're into like being organized and being able to refer back to work that you've learnt, so you can remind yourself and teach yourself how to do it, this is the slide that can go in your glossary today, because we've got a little bit of advice for you and a few steps for you to follow. So what we want to do is we want to add 2/3 and 3/5. I've put a visual indicator of those two fractions there just to kind of show you why we can't just add them together. It's because we're working with different sized pieces, right? Thirds are different in size than fifths. Thirds are bigger than fifths. We can't just add 2 of something and 3 of something and say we've got 5 of something if those somethings are different, right? I can't really combine these together into a nice kind of cohesive whole, right? I mean, if I try and put them together, pieces are overlapping with each other. If I try and move it around, like make them, I don't know, cuddle or something like that, I'm still not getting an idea of like how much of a whole I've got now, right? It does look to me like our answer is going to be bigger than the number 1, right? These two parts of a circle make more than a whole circle, but we can't add them together nicely and neatly because thirds and fifths are completely different. So the advice we're giving you today, it's not always the best way to do it, but since we're not there in class to kind of give you a bit of nuance and subtlety about the way you do it, this is the way we're going to advise you to answer these questions. To add fractions of different types, you can always start by multiplying each fraction, the top and bottom, by the other one's denominator. Okay, what that means for this problem is I'm going to times the top and the bottom of this fraction by 5. This 5 is kind of coming over here to do that. And I'm going to multiply the top and the bottom of this one by 3. And I got that from this fraction here. It'll give us common denominators, and it'll make sure these fractions stay equivalent, and we'll be ready to add them afterwards. So the first fraction, timesing the top and the bottom by 5, gives me 10/15. Right, we should be thinking, because I've got a 3 and a 5, thirds and fifths, that 15s are where I'm going to be headed. So I convert them. This is 10/15. This is 9/15. And now we have fractions, so we can actually add together, because we've made 15ths. We've kind of chopped these up into more parts. So we've got 15ths here and 15ths there. And now we can just add them, right? 10 plus 9 is 19. Unfortunately for you guys, some of the work we set today will require you to simplify or convert. If you don't have the simplest form of your fraction, right? If there's something that goes into the top and bottom evenly, you should simplify it down. You know, if you add things together and get 2/4, your answer's a half. This one needs to be simplified by converting it into a mixed number. 15 goes into 19 one whole time. And when I use up 15 of those pieces from the 19 that I had, I get 4 pieces left over. So the final answer is 1 whole and 4/15. All right, so there's a few steps to do. You can't just add from the start. You got to convert first, then you add, and then you got to check whether you can simplify or convert at the end. So hopefully those couple of examples of adding uncommon denominators will get you on your way, right? Make sure you never add things that are different, right? It's not something that can be easily done. Make sure you do that converting. This is a very important skill for you to practice, mainly just because it uses all the other skills we've built up in you so far, right? We're using equivalent fractions, simplifying, mixed and impropers, and all kinds of other stuff that'll really just help you practice all those fraction skills, right? So it's not a very exciting thing to learn how to do, but it's very, very useful to learn how to be adaptable and take things that are different and make them the same before you can add them together. And if nothing else, it'll help you pass your fractions test, right, at the end of this unit, right? So you've got questions to answer in Google Classroom. You've also got stuff on Mathletics that you should be keeping up with. So let's get to work.